Welcome back to another one of my integration examples videos where I run through 3 examples and show you how they're done. Each video will this is the 4th one obviously, but each video gets either harder or I add new techniques in that you might not have known or different ways of solving problems. Anyway, on that note, let's get started with number 1. So example 1 is fx equals 1 on 10 minus 6x. So what we're going to do is what we usually do, find the integral of both sides, capital F, and 1 on 10 minus 6x dx. So what I'm going to do is substitution here. I'm going to sub u in for 10 minus 6x, which will give us derivative, which will just be negative 6. And then to isolate dx on its own, so we can input it here, we'll have dx equals du. We'll just switch these two around, and we'll have over negative 6. That way, when we have fx, it'll now look like the integral of 1 on u multiplied by du on negative 6, because we subbed in u for the 10 minus 6x, and we subbed in the du on negative 6 for the dx. Okay, now because du is essentially multiplied to 1 on negative 6, that's a constant, so we bring it at the front. 1 on negative 6. Okay, now we're just left to find the integral of 1 on u with respect to u. So we can write this as negative 1 on 6, it's the same thing. The integral is going to be ln of u, because the integral of 1 on u is ln of u, just like the derivative of ln of u is 1 on u. Then we'll have the constant, we'll add the constant, and we'll multiply the negative 1 over 6 in, and we'll get negative ln of u on 6, subtract c on 6. And if we input our u value again, to finish this off, we'll get ln of 10 minus 6x on 6 minus c on 6. Now I usually say something like h equals negative c on 6, and then I can just put plus h instead of this, but I haven't got heaps of constants to work with. That's not that bad to write, so I'll just leave it. Maybe just once, I'll just leave it. Okay, and over here we have example 2. fx equals 5 to the power of x. Okay, so the integral of both sides is going to equal fx, capital Fx, 5x on ln 5 plus c. You might say, well, that's quick, but that's only because I used the rule of the integral of ax equals ax on ln of a plus c. Okay, so I just used that, as you can probably see. But I'll do a proof video on why that happens if you're interested later, but for now, that's just the rule. It's probably in the back of your textbook, so it's not too difficult, that question. Now for our final example 3. We have fx equals e to the power of x on ex plus 1. Okay. So what we're going to do is we're going to find the integral of both sides, and I'm going to use the substitution. So I'm going to sub u in for e to the power of x plus 1. Derivative, well, the derivative of e to the power of x is just e to the power of x, and the derivative of 1 is 0, so I'm not going to bother writing it. And just like you would with the substitution rule, we've got to isolate dx on its own. So we just basically switch these two around, and we end up getting du on e to the x. Okay, we're going to sub in u, and we're going to sub in our new dx value, which will give us the integral of e to the x on u multiplied by du on e to the x. First, we can cancel these out because e to the x divided by e to the x is 1, and all we're left with now is 1 on u. Okay, so 1 on u should be pretty easy, we just did it, is ln of u plus c. And now we're going to sub back in u. We said that u was e to the power of x plus 1 and plus c, and that there is our integral. Now, this wasn't as difficult as the previous video, but I just added in natural logs and e's and exponents, and so hopefully the things are. If you didn't know much about integrals with natural logs or exponentials, hopefully you do a bit now. Thanks for watching and have a good day.